Good morning, everybody. This is Rajesh Mukherjee from Holden Institute of Technology. In our last lecture, we started our discussion upon function in C programming language. We have seen that function provide us a way to break a large program into small subprogram, which help us to manage the program more efficiently. We have seen that it adds code reusability and modularity. Also, we have seen that with the use of function, we have very much flexibility in testing. In our last lecture, we discussed that function could be of two kinds, user-defined function and library function. Library function are those which are already defined inside the header file, and user-defined function which user define based on their requirement. Apart from that, based on parameters and return types, we can categorize function into four categories. Function without arguments and without return value, function without argument but with return value, function with argument but without return value, function with argument and with return value. So if we go to our compiler and if we look back the last example we have understood in our last lecture, which is a greetings, that we want to write a program which will greet good morning to all. To do that, we had defined a user defined function greet which simply print a greeting statement, and we also defined a main function which call the greet function. Now see, if you very closely look inside, you will find out that this user defined function return type is void. That means there is this function is not returning anything, and because of that there is no return statement. Also, if you see the parameter field also free, it is blank. Why? Because this function does not require any parameter to carry out its task, and also it is returning nothing. So this actually falls under the first category, function without argument and without return value. Now if we execute that, see, it's working fine. Now if we go back to next, if you go back to our code, that function without arguments but with return value. So see that if I see an example like this, I already have written the code so that we can save time. See here we have written an user defined function get number which simply returning a value, right, which simply returning a value, but the parameter field is free. There is no parameter is required to carry out its task because simply it's giving a value, right? And in the main function, when we are calling this user defined function get number, we are also not passing any values. So if you see that here this function returning an integer value, and thus it do have a return statement, but it don't have any argument. So this kind of function we can say that function without parameters or argument but with return type. So if we execute that, it's returning fine. Now come to the next function with argument but without return value. This time we will write the function in such a way so that the function will take some inputs from the calling function but return nothing. So if you consider this code, see, it's simply taking this code display sum. This is a user defined function. It's taking two input integer as a integer values and perform some of them but returning nothing. There is no return statement, and also the return type of the display sum is void. And also in the main function, when we are calling the display sum function, we are providing only two values. There is no return. So if we execute that, see, it's returning 10 summation of 10 and 20 30. So sum is equal to 30, which is printing inside the display sum function. So this falls under third category where the function does not have any return value but have parameter and argument. Now if we go for the last one, the last category where there is a function which have both, which have return type, return value, and also argument. So for that, suppose we want to perform multiplication of two integer values, and for that we have declared two user defined function, one user defined function multiply, which basically take two integer values from the calling function and perform multiplication and return it. So for as it is returning an integer value, so return type will be integer. And also in main function, when I'm calling the multiply, we are providing two values upon which it will act, and the result it will return that going to be stored inside an variable result. Now see, if we run that, the product of 4 and 5 is 20. So there are four kind of function based on their return value and argument. So apart from user defined function and library function, a function can also be four type: with argument, without argument, with return value, without return value. Right. So we already have discussed this. Now come to the syntax about function declaration, definition, and call. We are already familiar with this based on our examples, what we have discussed over the class. So when we need to declare a function, we need to declare a prototype. We need to declare a prototype. For example, that we have seen that if I declare, see, this is working. We already executed that. Again, we are executing. But see, if I place it after the main function, it will give an error. Why? Because we know the execution in C programming language start with main function. So the moment it start executing, it's encountering multiply, but still now it is don't know what multiply is, because we have defined multiply after the main function. If I declare it before the main function, then see, it's fine. Why? Because the moment it's actually executing, it's no. So for that, what we need to do, we need to declare a function, or we need to declare a function prototype, which is nothing but a simple description of the function. So if we consider this particular function, the name of the function is multiply. It will return a value which will be integer of kind, and which works upon two integer values. So we can declare it like that: int multiply int int. See, this is a description of the function. What we are asking here, we are asking that there will be a function, user defined function, whose name is multiply, and which going to take two integer values and return an integer value. Now see, if we execute it, it's working fine, right? Now this is called the function declaration or function prototype. Definition we already know. Definition is nothing but body of the function, which do contain the code which define actually what the function will perform. And there is a function call, means how we can call a function. So if we go there, from the main we are calling the function multiply using this statement. Now when we are calling a function, and if the function does have a parameter, then how we are passing the value, based on that we can also have two kind of things, which is call by value and call by reference. When we pass the argument or parameter to a function by the value, it's become a call by value. But when we provide instead of value the reference or address, it become call by reference. Let's understand this. See, here we are calling the multiply function while we are providing two value 5 and 4. So simply when we are calling the multiply, we are passing the arguments as a value. It is called call by value. Very same, instead of 5 or 4, if I declare two variable a and b, and we provide a is equal to 5 and b is equal to 4, and instead of directly passing the value, I simply pass a and b. Both here also, in this situation also, we are passing the values. See, the result is 20. So this is called call by value. Now, instead of call by value, instead of that, if I, instead of providing the value directly, if I provide the address of this variable a and variable b, it becomes call by reference. See that instead of a, if I provide address of a and address of b, then it's become call by reference. And as I'm providing the address instead of value, I need to also make changes in function prototype. Now it's become a pointer. This is also a pointer. This is also a pointer. This is also a pointer. Now x, y are pointer, but we want the value. So value at x and value at y. Now if I execute that, see, the product is 20. Now what are the changes we made here? Here, instead of passing the value or directly, we are passing the address of the variable a and address of the variable b, and which going to store inside two pointer, integer pointer x and y. And value at those integer pointer x and y, we are multiplying and returning back. So in the function prototype also, we made the changes. So this is called call by reference. And instead of that, if I provide the value directly, means I'm directly providing 4 or 5, 4 and 5, it become call by reference. Sorry, call by value. Okay. Now there's another important topic in function, that is scope of a variable. Now see, when we come to the function, we can declare variable in two ways. We can declare a variable inside a function and outside of a function. When we declare a variable like here global variable, we declaring outside of function, it's become a global variable and it will be available to all the entire program. But when we declare something inside a display, inside a function, it only available to this function. So these are the scope. The availability of the variables actually called scope of a variable. So based on that, we can define the scope of a variable as local variable and global variable. Global variable here, global var, which can be available to entire program, and local variable here is a local var, which only available inside the display. So if we take an example, it will be much more clear. That suppose I declare void scope a function. I declare a user defined function scope. Inside that, I declare a variable int a where I assigning the value 50. Okay, and also I declared a main function which simply provide, also declare variable k where I am declaring 100. Now we are printing a is equal to percentage d a. Now try to concentrate on this. See, here we have declared, so I don't require this, sorry. Now see here, inside the user defined function scope, we have declared a variable a where we have assigned the value 50. Now we are printing that value from the main function, but we just have understood that scope of the local variable or availability of the local variable only remain inside that function where it is declared. So see, if I run it, it will give an error, because here in the main function it is not finding any variable in a as a because a is not available here. But instead of that, if I comment it and if I declare that a variable as a global variable 50, see, now it is available. Very same thing also applies here, that if I print here, if I print it here, and here if I declare a is equal to 50, and if I comment this, now see that here now we have declared the variable a inside the main function. So the scope of the variable a limited to main. Now if I run here, it will again give an error. So this is the scope of a variable, and based on the scope of a variable can be local variable and a variable can be global variable. So if I summarize, that if I declare suppose g is equal to 50, it will be considered as a global variable, and when we declare something inside a function, it will be considered as a local variable. Okay, so we will stop our class here. Very next day we will have another session on function, and there we will end this chapter. Thank you.